Good evening, students. I hope it is audible clearly. So just 1 minute, we will wait for everyone and we will start the class. Yesterday, Priyanka, I think you were not there. Don't miss the classes.
Yes, ma'am.
Okay, good evening, students. We will start with the class. I hope the PPT is also visible to you. Okay, our next lesson is that is electric potential. Okay, so in this electric potential, and capacitors, the energy stored yes, Komal, it is correct. Okay, so yesterday class homework answer, whatever you people got, you can just tell me in the chat box. Yes. So here we have the positive charge, and here one more positive charge is there. As you know that according to the properties of the charge, the like charges will repel each other. Therefore, whenever you want to bring this charge near to this charge, you need to do some external work, right? So whatever the external work you are doing per unit charge is called as what? Electric potential, denoted by the letter B here. Okay. So what is electric potential? Electric potential is nothing but the amount of work done per unit charge. So I can consider the one charge is at infinite distance and the other charge is here. When I want to bring this infinite distance charge within the electric field. Now you people know what is electric field, where the electrostatic force will act between the two charges. It is called as what? That range is called as what? Electric field. So when I want to bring the charge from infinite distance to this distance, here external work what you are doing, that per unit charge is also called as what? Electric potential. Okay. So electric potential is defined as the work done per unit charge. Here you can see the electrostatic potential at any point in an electric field is equal to the amount of work done per unit positive test charge from infinite to that point against the electrostatic force without acceleration. Yes. So this is the expression. We write the unit with the unit. Work done is and charge is expressed in terms of coulomb. So it is joules per coulomb is the unit, and this yes. So this is the basic definition. Then next, here one point is there, that is the potential at a point. Analytically, it is defined as a scalar function of the position whose negative gradient at that point gives the electric field. So here electric field ಮತ್ತೆ potential ಗೆ relation ತಗೊಂತಾ ಇದ್ದಾರೆ. So what is the relation between electric field and the potential? It is this. So here whatever this charge is there, potential is denoted by V and the electric field is denoted by E letter. I hope now it is audible clearly. That is, the electric field and the potential is given by the relation minus dV divided by dr, where this dr is the distance. Dr is the distance here. Okay. So when I write it in the vector form, vector formal bandaga illi unit vector n cap anna multiply ಮಾಡ್ತಾರೆ. So this is regarding the relation between the potential and the electric field. So now here we can discuss some of the points. That is 1 minute. Okay. First point is this electric potential is a scalar quantity. So you remember the electric potential is a scalar quantity. and the potential difference unit in barutte volt anta barutte. Then the electric potential at infinity, it will be 0. So what I am saying here, the electric potential at infinite distance, it will be 0. So 0 yakagutte heli, because when you see the derivation nimage avag artha agutte. The potential is given by, it is 1 upon 4 pi epsilon naught q divided by r. So r ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, infinite distance ಅಂದಾಗ it will become infinity. ಹೌದಾ? So what is anything divided by infinity? Anything divided by infinity value is what? 0 here. Yes. Then one more point, the electric potential is the property of a point and it is independent of the path traced by the charge. ಅಂತಂದ್ರೆ ನೀವೀಗ ಚಾರ್ಜ್ ಅನ್ನ ಒಂದು ಪಾಯಿಂಟ್ ಇಂದ ಮತ್ತೊಂದು ಪಾಯಿಂಟ್ ಗೆ ಡಿಸ್ಪ್ಲೇಸ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ತಗೊಂಡು ಹೋಗ್ತೀರಾ ಅಥವಾ ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ತಗೊಂಡು ಹೋಗ್ತೀರಾ, ಇಟ್ ಡಸಂಟ್ ಮ್ಯಾಟರ್. ಆಯ್ತಾ? ಸೊ ಇಟ್ ಇಸ್ ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಫ್ ದ ಪಾತ್ ಫಾಲೋಡ್. ಸೊ ದೀಸ್ 4 ಪಾಯಿಂಟ್ಸ್ ಯು ರಿಮೆಂಬರ್. That is, electric potential is a scalar quantity, then it is unit is volt, then at infinity the electric potential value is 0 and it is independent of the path followed. Okay, so this is some of the points regarding this. Then after that we have discussed what is the relation between electric field and the potential. Then the next concept, that is the potential difference. So now we have discussed about the electric potential. Potential difference andag enagutte, this is nothing but between 2 points al now consider ಮಾಡ್ತೀವಿ. So the electrostatic potential difference between the 2 points in an electric field is defined as the amount of work done in moving a unit positive test charge from one point to the other point against of electrostatic force without any acceleration. So almost same barutte. Navili bus just ಏನು add ಮಾಡ್ತಾ ಇದೀವಿ, that is from one point to another point ಅಂತ ನಾವಿಲ್ಲಿ ಹೇಳ್ತಾ ಇದೀವಿ. Okay, so this is regarding the potential difference. Yes. So expression you can see, that is VB minus VA is equal to W upon Q naught. Okay, then the next point is electrostatic potential due to an electric dipole at any point P whose position vector is R with respect to the midpoint of the dipole is given by. So here derivations I'm just as it is a synopsis we are discussing. So just I am telling you the formula, we are not dealing with the derivation here, because I think in all the school colleges the derivations everything you are learning now. So again, if you have any doubt, that we can discuss here, but simply we will not waste our time much in the theory part. Yes. So here first point, that is the electric potential expression you see, it is given by 1 upon 4 pi epsilon naught Q divided by R. Okay. So now don't get confused, ಆಯ್ತಾ? So ನೀವೀಗ ಕೂಲಮ್ಸ್ ಫೋರ್ಸ್ ಅಲ್ಲಿ ಏನಂತ ಕಲ್ತಿದ್ರಿ, it is F is equal to 1 upon 4 pi epsilon naught Q1 Q2 by R square. ಸೊ ನಾವು ಈಗ ನೀವು ಸ್ವಲ್ಪ 1-2 ಟಾಪಿಕ್ ಅಷ್ಟೇ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಿರೋದ್ರಿಂದ ಅಷ್ಟು ಕನ್ಫ್ಯೂಷನ್ ಆಗಲ್ಲ. ಬಟ್ ವೆನ್ ಯು ಫಿನಿಶ್ ಆಲ್ ದ 15 ಲೆಸನ್ಸ್ ಯು ವಿಲ್ ಫೀಲ್ ಕನ್ಫ್ಯೂಷನ್ ವಿತ್ ವೇರ್ ಇಟ್ ಇಸ್ Q, ವೇರ್ ಇಟ್ ಇಸ್ R, ವೇರ್ ಇಟ್ ಇಸ್ R ಸ್ಕ್ವೇರ್ ಅಂತ. ಸೊ ನೆನ್ಪಿಡಿ, ಕೂಲಮ್ ಫೋರ್ಸ್ ಅಲ್ಲಿ Q1 Q2 by R square ಬರುತ್ತೆ. When you see the electric field intensity, it is 1 upon 4 pi epsilon naught Q by R square. And when you come for the electric potential, it is 1 upon 4 pi epsilon naught Q by R. Yes. Okay, so I hope the 3 clear picture you have here. So force alli Q1 Q2 by R square, then field alli Q by R square, then potential alli it is Q by R. Okay, so now for the dipole we are seeing the expression. ಈಗ ನೋಡಿ ನಾವು dipole ಗೆ ಇಲ್ಲಿ ನೋಡ್ತಾ ಇದೀವಿ expression ಅನ್ನ. For the dipole it is 1 upon 4 pi epsilon naught P cos theta divided by R square. Yes, so P is the dipole moment here. Cos theta, that is the theta is the angle between, that is the arbitrary point and the dipole. Yes, and R square, R is the distance. Then in the vector form the same equation is written as 1 upon 4 pi epsilon naught P cross R upon R square. Yes, so this is electrostatic potential due to an electric dipole. Then the next equation, Yes, you require the derivation. Please let me know so that I can teach you the full derivation if you want. Otherwise, only main points I'll tell you so that we can go for more question answers. Yes, the electrostatic potential on a perpendicular bisector due to an electric dipole is zero. So this is a key point here. What is this? The electric potential at a perpendicular bisector. Antandre éನಾಗುತ್ತೆ? That is so here you can see the expression for the potential, that is 1 upon 4 pi epsilon naught P cos theta upon R square. Yes, theta. Theta, it is how much it is. If it is a perpendicular bisector, theta will be 90 degree. Yes. So when cos 90, you have, what is the value of cos 90? Cos 90 is 0. Therefore, the electric potential for the bisector, it will be 0. So these are the key terms. So ಕೆಲವೊಂದ್ಸಲಿ ಏನ್ ಬರುತ್ತೆ, theory based questions ಬರುತ್ತೆ, ಅಲ್ಲಿ ನಿಮ್ಗೆ ಇದೆಲ್ಲ points ಗೊತ್ತಿರಬೇಕು. Then the electric potential for the okay, I'll explain that derivation. Okay, so this one point I'll teach, then I'll explain you the derivation. See, electrostatic potential at any point P due to the system of n charges, it is given by. So for this, how we will take, that is actually we will consider the charge point P, and this point P is surrounded by the charge Q1, Q2, Q3, then Q4, like this up to n charges we will consider this. Okay, so this distance between the point P, which is taken as R2, between this actually should in between I'm losing the connectivity because of the rain here. Okay, so we were discussing about the electric potential for the n number of charges. So this is Q1, that is Q2, this is Q3, and this is Q4. This point P is surrounded by n number of charges. The potential is given by, so just now I told you it is V1 plus V2 plus V3 plus and so on up to Vn it is, which is equal to. So 1 upon 4 pi epsilon naught, it will be common for everything, every charge here, every potential. Therefore, it is Q1 by R1 plus Q2 by R2 plus Q3 by R3 plus and so on up to it is Qn by Rn. Then next 1 upon 4 pi epsilon naught. Here what we will do, we will take the summation. Yes. So summation, the I is running the value from 1 to n. Then so Q1, Q2, Q3 up to n. Therefore I'll take it as Qi and denominator I'll take it as Ri. Okay. So ಇಲ್ಲಿ ನೀವೇನು equation ನೋಡ್ತಾ ಇದ್ದೀರಾ, that they have taken it as for the means that difference of the distance they have taken instead of taking it as Ri. So you can take it like this also, you can take it like this also. Both will be fine. Okay. So now we will see the derivation for the electric potential due to the point charge. Yes. So how to do that derivation? So it is a 3 marks question for your either unit test or any test you can see. Okay, Anvita, Priyanka, Komal and Netravati, we will continue on Wednesday class. Because of the rain, I am not able to connect you properly. I am losing the network. So Wednesday class, we will continue this. Because many times it is going. Okay, Wednesday we will continue. Okay, sorry for the interruption.